Our bodies are incredible machines, constantly working to keep us healthy. One of the most important systems in our bodies is the immune system. It's our own personal defense force, always on the lookout for harmful invaders like bacteria, viruses, and other germs that can make us sick. Think of your immune system as an army with different types of soldiers, each with a special job to do. Some soldiers act as guards, patrolling the borders of our bodies to keep germs out. Others are like detectives, identifying and neutralizing threats. And still others are like memory keepers, remembering past battles to help the body fight off the same invaders more effectively in the future. The immune system is incredibly complex, but understanding the basics of how it works can help us appreciate its importance and take better care of our health. In the following sections, we'll explore the different parts of the immune system and how they work together to protect us from harm. From the moment we're born, our immune system is hard at work, learning to distinguish between our body's own cells and foreign invaders. This remarkable system is what allows us to live in a world teeming with microbes, most of which are harmless, while protecting us from the ones that can cause disease. So the next time you feel a little under the weather, remember the amazing work your immune system is doing behind the scenes to keep you healthy. Our bodies have an impressive array of defenses to keep germs at bay, even before they have a chance to cause trouble. Think of these defenses as the walls and moats of a castle, forming a protective barrier against invaders. Our skin, the largest organ in our body, acts as a tough and waterproof barrier, preventing most germs from entering. The mucous membranes that line our nose, throat, and lungs trap germs with sticky mucus, which is then swept away by tiny hairs called cilia. Saliva in our mouths and tears in our eyes contain enzymes that break down bacterial cell walls, while the acidic environment of our stomach juice kills many germs that enter our bodies through food or drink. These physical and chemical barriers are our first line of defense, working tirelessly to keep us healthy. These defenses, however, are not foolproof. Germs are constantly evolving and finding new ways to breach our defenses. When they do manage to get past our first line of defense, our immune system is ready with a second line of defense, the innate immune system, which we'll explore in the next section. Imagine a fire breaking out in your house. The first responders, like firefighters, rush to the scene to contain the blaze and prevent it from spreading. Similarly, when germs manage to get past our initial barriers, our innate immune system acts as the first responder, launching a rapid and non-specific attack. This part of our immune system is made up of various cells, including phagocytes, which are white blood cells that engulf and destroy invading germs through a process called phagocytosis. Think of them as the Pac-Man of the immune system, gobbling up harmful invaders. Another important part of the innate immune response is inflammation. When tissues are injured or infected, the body releases chemicals that cause blood vessels to dilate, increasing blood flow to the area. This brings more immune cells to the site of infection and helps to contain the invaders. Fever is another common response of the innate immune system. By raising the body's temperature, fever makes it harder for germs to survive and helps to speed up the immune response. While uncomfortable, fever is a sign that your immune system is actively fighting off an infection. While the innate immune system provides a rapid and general defense, the adaptive immune system is a more specialized force that targets specific invaders. This part of the immune system is responsible for recognizing and remembering specific germs, allowing for a faster and more effective response upon subsequent encounters. The key players in the adaptive immune system are two types of white blood cells called T cells and B cells. T cells, which mature in the thymus gland, are responsible for cell-mediated immunity. They directly attack and destroy infected cells, acting like assassins targeting specific enemies. B cells, which mature in the bone marrow, are responsible for humoral immunity. They produce antibodies, which are specialized proteins that bind to specific antigens on the surface of invading germs. These antibodies act like wanted posters, marking the invaders for destruction by other immune cells. The adaptive immune system is what allows us to develop long-term immunity to certain diseases. Once our bodies have encountered a specific germ and mounted an adaptive immune response, we are less likely to get sick from that same germ again. This is because our adaptive immune system remembers the invader and can mount a faster and more effective response the next time around.